Today we're going to talk about frequency distributions and statistical graphs. So in the last section, we talked about some different statistical definitions. So we talked about some different ways of collecting our data from different types of samples. In this section, what we're going to do is we're going to look at a way to organize that data. So how can we effectively summarize that using either tables or graphs? So the first way that we're going to do this is we're going to use a frequency distribution. So when we're thinking about statistical investigations, our first step is always going to be to visualize the data. If we're looking at just a data set list of numbers, it may be difficult to see patterns, it may be difficult to see trends, and there might be more questions that we want to ask about the data than we can if we're just looking at a set of raw data. Okay, so what we're going to start with and what we're going to look at first is we are going to look at a frequency distribution. All right, a frequency distribution organizes our data. It records and it gives us two things. As we're looking at these, we're going to see two different columns. We're going to see our observed values and then the corresponding frequency or count of the occurrence of each value. All right, so in this particular example, here's a list of raw data from the NCAA. This set of data shows the number of goals scored by first-year female soccer players in Division III in the 2012 season. Right, so what we see underneath this little paragraph is just a list of numbers. Right, looking at this list of numbers, we can see some different aspects of our data, but we want a nice way to summarize this. So what we're going to do is we're going to count how many each time these different values occur in our data set. So if we look at this, our first entry here is 9. So we had one person, right, one athlete that scored 9 goals. If we look at 11, 1, 2, 3, 4, we have 4. If we look at 12, we have 1 again. 13, 1, 2, 3, 4, 5. 14, we see 3. 15, we see 2. 16, we count 4. 18, we count 2. 19, we also have 2. 20, we have 2. We have one person that scored 21 and one person that scored 35. So our frequency distribution, we take all of our different data values and we count how many times each of these occur in our data set. If we look at our list, if we count all of these individual entries and or if we add up all of these numbers here, we should get the total. So if we add all of these up, we get a total of 28, which if we were to count all of these individual data values over here, we have 2 rows of 14 values, which gives us 28 values. So as you're working through these problems, one thing to kind of double check your answer, feel free to total up everything in your column as you're working through your frequency distribution and make sure that it totals the correct number of values in your original data set. Right, so sometimes when we're dealing with frequency distributions, we may have a very large data set that has a lot of different values. So one thing that might be useful for us is to not necessarily organize our data just by individual data values and count individual data values. We might want to split these into groups. Right? So we can also create frequency distributions that organize data by grouping the values into these groups we call classes. Right? The width of each of these classes is always going to be the same, so we have the same size group for every single part of our problem. It is often suggested that a frequency distribution should be constructed with 5 to 12 classes. This size shows detail while also maintains clarity. Right? So we don't want a frequency distribution with 100 different classes because that's too many. At the same point in time, we don't want 1 or 2 classes because that doesn't give us enough detail. All right, so our lower class limit is the smallest value within the class. Our upper class limit is then the largest value within our class. The class width, right, is the difference between 2 consecutive lower or upper class limits. This is how big of a group we have. This is how big our class is. The modal class is the class with the greatest frequency. We'll see the word mode again in the next section as well. And then the midpoint of our class, right, is also called the class mark. Okay? And it is found by adding the upper and lower limits and dividing the sum by 2. Okay. So now if we look back at the same example that we had on the previous page, now instead of looking at individual data values here, we have classes. Right? So first thing that we're going to do, we're going to go through and fill in the number of athletes in this column to construct our frequency distribution, and then once we have that done, we're going to go ahead and answer some other questions. All right, so in the class from 9 to 11, we have 1, 2, 3, 4, 5 values. Right. 12 to 14, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Right. From 15 to 17, we only have 15s and 16s here, but if we count those, we have a total of 6. Okay. 18 to 20, 1, 2, 3, 4, 5, 6. 21 to 23, we just have 1. We don't have anything in 24 to 26, 27 to 29, or 30 to 32, so all of those are going to get zeros. And then our 33 to 35, we just have 1 value. Right, so unlike our last list where we only had classes, or excuse me, we only had rows in our frequency distribution that had values, here we have some zeros in this frequency distribution. If we total these up, we should also get 28, the same as we did in our last frequency distribution, which is going to be our total number of observations. All right, so we're going to take this frequency distribution that we just created and then answer these questions that are down at the bottom of the page as well. Right, so our total number of observations, right, we just said was 28. We had 28 different data values in here. Again, whether we count our individual data values or we add those, either way we get 28. To find our width of our class, we are going to subtract either 2 consecutive upper or lower limits. So looking at this, we can pick pretty much whatever values we want. So if we wanted to use lower limits, we could use 9 and 12, 12 and 15, any of these pairs here, as long as they're consecutive. Upper limits, we would use our values over here. Easiest thing to do, just take a look at these first 2 values and subtract them. Right? So 12 minus 9 using these lower limits gives us a class width of 3. And if we think about that, that should make sense. If we count 9, 10, and 11, that's 3 numbers. Right? So we have 3 numbers that are contained in that class. That is our class width. Our midpoint of our first class, we're going to take our upper and lower limit and then divide it by 2. So our lower limit is 9 plus our upper limit is 11 divided by 2. 9 plus 11 is 20. 20 over 2 is 10. Again, that should also make sense looking at our 3 data values. Well, 10 is halfway between 9 and 11. With bigger classes, the midpoint, it will always be the middle of our class. But if we have a class size that's larger than just 3 values, it's not going to be the only one that's missing in that list. Right? Our modal class or classes is the one with the largest frequency. Right? Our class with the largest frequency, we have a frequency of 9 for our class that has 12 to 14 goals. So our modal class is going to be 12 to 14 goals. Okay. The class limits of the next class if an additional class were to be added. Right. So if we look at these last 2 limits, our lower limit is 33. Right? And if we look at these, our class width, our difference between all of these is always 3. So to get our next class, if we add 3 to each of these, those will give us our next class if we were to add another one for class limits. So if we add 33 to and 3, we get 36. And if we add 35 and 3, we get 38. Okay. So if we were to add an additional class, that next class would have limits of 36 to 38. Once we construct our frequency distributions, sometimes we might want a more visual representation of our data set. So in these next couple of examples, we're going to look at some different statistical graphs that we can use based off of these tables. Right? So the first one that we're going to look at is we're going to look at a frequency histogram. A frequency histogram is a bar graph. A frequency histogram is a very common way that we see statistical data organized and presented. Right? So as we're going through these next couple of examples, we're definitely going to construct some frequency histograms, which are going to be more along the lines of bar graphs. Right? A frequency polygon is going to be a line graph. So after we get done constructing a frequency histogram from this data set, we're also going to construct a frequency polygon. All right, so in this example, the following data represent the number of children per family for 30 families surveyed. Right? So the number of children is our observed values, so we see 0 to 6. The number of families is our frequency. Again, if we were to add these all up, we should get a total of 30 because that's the size of our data set. Right? So what we're going to do is for each of our different observed values here, we are going to enter our corresponding frequency. Right? So looking down here, I'm just going to label my axes. So we're going to label these number of children. And then our vertical axis is going to be labeled in frequency. Okay. All right, so looking at our table, there are 4 families that have 0 children. So we're going to come down here to our frequency histogram. As we're doing these, we generally center the bar that's above each different value, or midpoint as we're going to see in the next point. So for our 0 value, we're going to draw a vertical bar that goes up to a frequency of 4. Okay, if we go up to our table, the number of children, if we have 1 child, there are 6 families. So above 1, we're going to construct a vertical bar that goes to a height of 6. Right, there are 9 families that have 2 children. So we're going to construct a vertical bar that goes up to 9. There are 5 families that have 3 children. So we're going to construct a vertical bar that goes up to 5. There are 3 families that have 4 children. There are 2 families that have 5 children, and 1 family that has 6 children. So there is our frequency histogram. Our frequency polygon, we're going to use the same values, but instead of having a bar graph, we're going to have more of a line graph. So what I'm going to do is above each of these different values for our number of children, I'm going to put a dot at their frequency. Okay, so 0 children, there's 4 families. Right. For 1 child, there were 6 families. 2 children, there were 9 families. 3 children, there were 5. 4 children, there were 3. 5 children, there were 2. And 6 children, there were 1 family. All right. So we're going to connect this. We're not going to worry about making it a nice pretty curve or anything. We're just going to use little straight lines to connect each of our different values. Right? So there is our frequency polygon. As you're working through the homework, you're going to be asked to create both of these different things. Right? So histogram, you're thinking bar graph. Frequency polygon, you are thinking a line graph, connecting the different dots for our different values. Right, in this next example, we're going to create another frequency histogram. Notice that this time we have classes instead of just individual data values. So as we are doing these, we're going to create a frequency histogram, and then we can create a frequency polygon on the same axes. We're going to use our class marks to label our horizontal axis. Remember, our class marks are our midpoints. So if we look at our first class, right, we're going to find our midpoint. 1 plus 7 over 2 is equal to 8. Right? Then if we were to find our next midpoint, right? 8 plus 14 over 2, or excuse me, 8 for the last one, 8 divided by 2, I forgot to do the division part, which is going to give us 4. 8 plus 14 gives us 22. 22 divided by 2 gives us 11. Right? And we could continue doing the addition and division for each of these, or we can use kind of a little trick to help us speed up this process. Right? If we look at these, our class width is 7. Right? Our difference between 1 and 8 is 7. Our difference between 8 and 15 is 7. Our difference between 7 and 14 is also 7. If we look at our distance and our midpoints, that is also 7 as well. Right? So instead of going through and doing the addition and division, we can just keep adding 7 to get the rest of our midpoints, or the rest of our class marks. So we add 7, we get 18. Add 7 again, we get 25. Add 7 again, we get 32. And add 7 again, we get a class mark of 39 for this last one. All right, so underneath here then, for our frequency histogram, right, we are looking at our distance in miles, and we're going to use these midpoints, or these class marks, to label our horizontal axis. So 4, 11, 18, 25, 32, and 39. Right. Our vertical axis is still our frequency. Okay. So our frequency histogram, we're going to use our numbers listed up here in this table to draw our vertical bars to the appropriate height. Right. So our first class has a midpoint of 4, and it had 15 workers. So we're going to draw a vertical bar going up to 15. Our next class had a mark or midpoint of 11. That's going to go up to 24. Right. Our next one had a midpoint or mark of 18. There we have 13. Right. Our next class, we have a frequency of 8. Right. The next one is a frequency of 5, and our last class is also a frequency of 5. So there is our frequency histogram. Right. Now, if we wanted to overlay a frequency polygon on top of this, what we would do is we would put a dot in the center of each of our bars. Right? So that way it's directly above our class mark. And then we could go through and connect those dots to give us our polygon for our line graph. All right. So the advantages of frequency histograms and frequency polygons. Again, we tend to use histograms a little bit more than we use polygons. The nice thing is they're very good for large sets of data because we can put these into classes and then draw a representative graph based off of these classes. They show the general shape of the data. So whether we're looking at a histogram or a polygon, we see the general shape of our data set. And it's easy to spot data that do not fit the pattern. So if we went back to our first example where we had one value of 35, we would see pretty clearly and pretty easily that we definitely have some data that did not fit the pattern. The disadvantages of histograms and polygons, individual data values are not visible. Right? So in this particular case, we don't know all of our individual data values from this data set. We were just given information about these 70 employees in our different classes. Right? So we lose a little bit of the individual data values. And then the other possible downfall for histograms or polygons is if we change our class width, our shape could be affected. So that's why we don't necessarily want too many classes or too few classes. We want kind of a nice range that's going to be a good representative shape.